Find all zeros of the polynomial 4x to the fourth minus 20x cubed plus 35x squared minus 25x plus 6. We'll start out by using the rational zeros test. Remember that our possible rational zeros are those numbers of the form x equals q over p, where q is a factor of the constant term and p is a factor of the leading coefficient. So if we look at the set of all possibilities we've got here, factors of 6 include 1, 2, 3, and 6. Those are the only numbers that go into 6 evenly. Factors of the leading coefficient, 1, 2, and 4. And then we have every possible sign variation on these. So if we were to list this out, we have 1, 2, 3, and 6. Just taking each of these and dividing them by the first number. We have, take this entire list and divide it by 2. This would include 1/2, 2/2, which is the same as 1. We already have that in our list, so we don't need to repeat it. 3/2, 6/2, which is 3, but we already have that in our list. And then finally, we take each of these numbers and divide by 4. So our first is 1/4. Our next would be 2/4, which is 1/2. That's in our list already. Next, 3/4. And then finally, 6/4, which can reduce to 3/2, which we already have in our list. And we have every possible sign variation on those roots. Now that is a lot of zeros. So to see if we can narrow this down a little bit, we'll apply Descartes' rule of signs. So for Descartes, we want to look at the possible positive real zeros and the possible negative real zeros. We want to get a count on these, how many we can possibly have. So remember, to do this, we're going to count the sign changes in the original polynomial. So the original polynomial was 4x to the fourth minus 20x cubed plus 35x squared minus 25x plus 6. And if we count the sign changes here, the sign changes from positive to negative. So there's one sign change. And then from negative it changes to positive. That's our second sign change. Then from positive it changes to negative. That's our third sign change. And then from negative it changes to positive. So it changes sign 4 times. This tells us we have at most 4 positive real zeros. But remember, we can lose these in pairs. So we have 4 or 2 or 0 positive real zeros. If we look at how many negative real zeros we have, well, we're going to replace every x in the original polynomial with negative x. That has the effect of negating all of those terms with an odd power of x. So writing this new polynomial out, we have 4x to the fourth plus 20x cubed plus 35x squared plus 25x plus 6. And if you look at this, every term here is positive. This says there are no sign changes. That means there can be no negative real zeros. Since there are no negative real zeros, that means we can update our list. We can throw out all of the negative roots. So that cut our list in half. We only have to check this list of 8 zeros. So now that we've narrowed our list down, now we're going to do a little bit of trial and error using synthetic division. So I'm going to start out with just the first number in the list. I'm going to start out with x equals 1 and set up our division bar. And remember, for synthetic division, we copy down the coefficients of the original polynomial. So 4, negative 20, positive 35, negative 25, and positive 6. For synthetic division, we first carry down the leading coefficient. Then we multiply. 1 times 4 is positive 4. We then add these together to give us negative 16. Then 1 times negative 16 is negative 16. We add these together. This gives us positive 19. 1 times positive 19 is positive 19. We add these together to give us negative 6. 1 times negative 6 is negative 6. We then add these together to give us 0. Remember, this corner entry is the remainder. And since the remainder is 0, this tells us that x equals 1 worked. X equals 1 is a 0. Well, x equals 1 worked. Let's continue on in the list. Let's try x equals 2. So I'm just going to take the answer we had already and set up the synthetic division from here. So our first step again is to bring down the leading coefficient and then multiply. 2 times 4 is positive 8. We add these together. We've got negative 8. We then multiply. 2 times negative 8 is negative 16. Adding these together, we have positive 3. Then multiply. 2 times positive 3 is positive 6. Adding these together, we get 0. So our remainder is 0. This is great news. This means x equals 2 worked also. So x equals 2 is a 0. If we look here, the original polynomial was degree 4. So after the first synthetic division, we were left with a degree 3 polynomial. After the second synthetic division, we're left with a degree 2 polynomial. So writing this out, this is 4x squared minus 8x plus 3. Now we want to know when this is 0. So we'll set this equal to 0 and then solve this. We can either solve by factoring or using the quadratic formula. On this, I happen to notice that this polynomial will factor into 2x minus 1 times 2x minus 3. Although if you don't see that, then go ahead and use the quadratic formula and you should come across the same answers that we get here. We're now going to set each of these factors equal to 0. So 2x minus 1 equals 0 and 2x minus 3 equals 0. And then solve each of these for x. So the first factor will give us x equals 1/2. The second factor gives us x equals 3/2. So they asked us to find all the zeros. We have x equals 1, x equals 2, x equals 1/2, x equals 3/2. We have 4 zeros, and this was a degree 4 polynomial, so we know we found all the zeros.